simple functions. A function to implement, it does unusual things with really relatively a minimal amount of code. So what you do is to try running this example, 1627 to 1635. So you understand what's going on. First, confirm that it works, then see if you understand what's going on. And you said a lot of the functions that I'm using in this sequence of examples are recursive. Okay. So just a comment, you ask people to break this down, tell me what's going on. The understanding functions that I was taught in graduate school that I found really helpful is the functions in terms of their signatures, in terms of their types. As a signature, this Fibonacci helper function is integer to integer, integer, integer. You notice that each case of the Fibonacci helper function returns a triple. And triple happens to be the current value of the Fibonacci series, the previous value, and the previous. The reason for returning three values consistently is the definition of Fibonacci series says that in order to derive the next, you take the previous and you add it to the one back before that. So class Fibonacci, 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 2 plus 5 is 8, and so forth on out to 2,178,309 plus this large number, that large number. Okay. So one of the points that I teach people when I try to teach recursive programming is that if your function is not returning the same type of object in each of its return cases, then you are probably doing something wrong. As you can hear, each of these cases is returning triple. So ultimately, when it's time essentially what the Fibonacci function does is computes Fibonacci, say, the 17th or the 34th in the Fibonacci series. It tripled represents, say, for the 17th value, the 16th value, and the 15th value. And then we keep the 17th value around. So, before I go any further, quick room. Patty is going to say about how this function is designed. Does that make sense to you at all? Okay. Okay, so you can see if I can do things a little bit differently. How about this? That helps at all. Ryan, you follow what I'm doing here? Huh? Those are squares. Those are squares. Yes, it is. In Python, if I can other languages, use for as a variable. And I could have just called it ignore this value. Okay, so I'm just using it as ignore this value because I don't need, in order to return the next, I don't need which now 3 back. I only need which 1 back and 2 back. Okay, so we get another concept I thought helpful for getting other people is if you don't understand the big result, try to understand each of the small steps. If it would help her, I think this is a little clearer as to what it is doing. Please, are you following what's going on? Yes. Are you following what's going on? John? Patty, are you following? Dave, happy. Is Dave?
He is muted.
Okay.
And Dwayne has joined us as well.
Okay, since Dave is muted and Dwayne just joined us, I will rely on Dave and Dwayne to speak up.
I should be there. Can you hear me?
Yes, we can.
Okay, sorry.
So, no, if you have any concerns, say, I'll rely on you.
Sounds good.
Okay, so what I'm about to do is look through a second example which I have re-entered Fib a little bit that I think is really cool in terms of program design. And this second example is, well, a couple things. Let's first follow the line 1643 to 646. Running those. Okay, so Python environments are lists. Python keeps a dynamic list of all names that are defined in a context, any point in your section. And you've seen that already. You've seen functions, we've defined functions, we've undefined functions, and the functions have disappeared. So what's out there is called, at the top level, is called globals. Okay, so what this three-line snippet does is it's first of all establish that Fib helper is defined, takes the globals list, and essentially tosses the helper. The second line is an equivalent of saying del, Fib helper. Well, third step could be undefined as the third step because the second statement throws away the helper. That statement is equivalent of saying del, Fib helper. When you see del, Fib helper, what you're actually doing is you're instructing Python to go to your environment, and your environment is a list of all the names that are active. Python actually keeps a dynamic symbol table of all the identifiers you have in play at any point in your session. That list is called globals. And foo is the equivalent of saying globals dot top foo, the top level of your session. And I'm introducing this particular idea because I'm going to be talking about scoping in Python in a little bit. And keeping in mind that there are really three scopes. One of the scopes is globals. The global scope is what you have to talk to the environment. And then reference the global scope. Now, what I'd like you to do is to look at run lines 47 to 1657. Before you do that, the point of this second reading of the Fetchy example is namespace cleanliness. In the example, you had this thing called Fib helper. Fib was sitting out at the top of everything, and Fib helper was not really designed to be used directly by users. Designed to be used directly by users, but you had Fib helper exposed in the global environment. The example does, and I don't know whether Java allows you to nest function definitions. I know for a while that after you got away from ALGOL, that standard third generation languages did not allow you to nest function definitions. Python does. And I like that because one of my standard design tactics when I'm designing functions is if I need a helper function, I am the helper function inside the outer function, so the helper function is only visible to the function that acts as a service. So try that out. You should find that works exactly the same way, and that it varies the helper.
This would take the global thing.
Uh-huh.
Yay, Ryan! It worked with you.
I had to find I can't reload. This is global.
Huh. Yeah, it definitely. Yeah, I remember an old article, I have it saved somewhere. How to shoot yourself in the foot in different languages. Plus for I equals 1 to 10. Do pull down and shoot foot. That sort of. Okay, so click for the room, and I'll do what I do in my class, is start with different people at different times. Start, Ryan, are you satisfied with the 6-second example? Having blown up your environment, yeah. John? Okay, are you satisfied with the, Bob, are you satisfied?
Oh. I'm Yeah.
Okay, so the point is, Python, like a few other languages I've worked with, and unlike a lot of others, allows you to vary functions within functions, which can be a nice little design tool. Okay, so here's a third example. Now, this is the classic definition of Fibonacci. I'd like you to run lines 1663 and 1665 and tell me when you're done.
Oh.
Like we're put on a pot of coffee and there was my stack. Are other people's stack? Just a performance bit. Okay, so Fibonacci is also neat because it's the classic example in elementary software classes for how to do things right and how to do things wrong. What you have is a space-time trade-off. The space trade-off is you're not keeping around the spare values from past to past. You're not remembering the previous, you're not remembering the second previous. Time trade-off is essentially this classic definition results in exponential growth. For example, in order to compute, and I had a picture of this somewhere, I don't have it with me right now. Essentially, if you're going to compute fib 3 this way, computing fib 2, in fib 2, you have to compute fib 1, which is direct, then you have to compute fib 0. In order to compute fib 3, you also end up recomputing fib 1. It doesn't look too bad. Compute fib 4. Compute fib 4, you have to compute fib 3, and you have to compute fib 2. Set this so I have the tabs going. Okay. That's what happens when you go to compute fib 4. Now, when you compute fib 5, according to this definition, you end up computing fib 4, and you end up computing fib 3. As we go to compute fib 6. People get the idea. What's happening is you're doing a lot of very stupid computation across the computation of fit. Now, Python, like there's a speech I learned about back in graduate school 30 years ago called normalization. And like a lot of other good ideas, it's found its way into mainstream programming languages eventually. With memoization, I saw this feature with Python, but I've since seen this, I believe, in Java and newer versions of Java, and Sharp also introduced the idea of, they're called in Java, and I don't know what they're called in C#. In Python, they're called decorators. What a decorator does, decorator is what's called a functional. A functional is a function that accepts a function and returns a function. You can think of a Python functional as a wrapper mechanism. So what typically happens with Python decorators is you take a function and wrap it in sort of pre-processing and or post-processing logic that enhances the value of the original function. Another thing that the decorator does is it's wrapping your start function. You rename the wrapper and replace the name of your starter function in your environment with the wrap function. To examine more carefully, I start with a function f, and I create f. What happens is I get this thing which we'll call decorated f of some anonymous name. And the decorator finishes up by taking decorated f thing and reaching out the definition of f in your environment, the original f. This idea of decorators I'm seeing now in C# and I'm seeing Java. Okay. If you can actually write your own decorators, and if you're interested in this sort of black magic, the Seal book has a nice breakdown. I think the Lutz book probably has a nice breakdown of exactly what's going on with decorators. Python's syntax for decorators took a little getting used to. Okay, you specify a decorator connecting to a function in Python. In @sign, you write them at the decorator, and the function immediately below. The LRU cache decorator does is incorporate the concept of memoization into your function. Now, what happens with memoization is that the original function gets enhanced with processing logic and processing logic that creates a word internal table. What decorator will do is we'll start in a table. Fib1 is 1. Fib2 is 1. Fib3 is 2. Fib4 is 5. Fib5 is 8. So as the decorated function runs, the table gets built up. And the processing says, if I have a K that I've already seen, rather than going all the way back through the headache of trying to recompute what, just the value out of my table. And assumption that the function is static in the sense that the function always maps a certain input to a certain output. So I'd like to now is run line 1671 to 1676 and compare the processing time that on the previous example with the processing time you get. answer for you.
Seems like the decorator covers bad code.
Well, in case the decorator covers bad coding, the decorators serve a variety of purposes. When we get to the object-oriented part of this seminar, the never-ending seminar of Python, you will see is that decorators are used in the object-oriented core Python language to do things like static methods. Abstract base classes are all implemented using decorators. So, this other thing. Notice the max size argument. I played with the max size argument. Max size none means that keep holding the table until Python's memory fills. Right, my normal table. For example, try max size equals 18. I never tried that. See what happens if you say max size equals 18. Back, LRU cache, max size equals 18, define fib, and rerun the fib example. Let's see if it slows down. Let max size equals 10. Pretty good. So max size equals 4. Max size equals 2. For max size equals 3. Max size equals 1. Now we have max size equals 1 and starting to it's right. What if I have a chance to teach Python? Now we're doing this is to try to see what happens. When you start to get this to grind, I was wondering if max size equals 2 would cause no. Max size 2 does have a little bit of a slowdown. It looks like the processor anyway. It's a grind whenever you get up around 35 or 36. Okay. Going, John, any questions about graders or about the
I'm just saying that you're going to read that code. You know, the real small about that. What's going on?
part of the language for somebody who doesn't know object-oriented programming. The idea of saying that something is final or something inherits from something else is also hard to read. When I was first learning C++ after years of doing Pascal, about how hard it was to get the idea of abstract concrete classes. So you become used to it. And one of it's there in C# now. It's there of it. And one of the ideas to help me become comfortable with the idea of decorators is the notion that decorators can only function as wrappers. Okay. Ones I've worked with.
This month is.
Yeah, it looks wild when you first see it. Patty, are you
It's what? I'm good.
Bob with that? Ryan, you good with that? Okay. So here's things that you're probably not used to either. Closures. I like run the examples in line 1683 to 1691.
Hold on.
This sort of stuff goes all the way back to the 1950s. This is classic Haskell Curry. Haskell, you follow what's going on. Another such theme is the special instantiation. You have a function, and you specialize a function to a particular argument, and then it gives you back, kind of like going from a more general function to a more special function, more specialized function. Are you comfortable with what you're seeing? Not comfortable with, you understand what you're seeing here. That's real. Do you follow what you're seeing here?
Well, we need more parentheses.
And color.
No, it's only.
You don't have that typo.
Well,
Ryan, are you following what's going on here? Yes, because effectively what's happening is that the n is being stored as part of the local state for the function. John, should with negative one. I see. Run it.
So I tried to do actual plus this for negative 19. Plus. One for n, parentheses minus 19. Which n is negative 19. Anyway, here's what, here's the key point.
Well, what you could do, what were you doing, John? Were you,
Plus underscore minus one. Plus underscore minus one. Plus underscore n. Plus.
what?
Yeah, the minus. And it's dash minus.
Uh, so I just did that, but work. Because N is part of the name.
What? N is the name.
You could have called it plus fluid. N. The N in the name is different from the N in the signature.
Alright, if your first line of your store, you just cut to the negative one. You want
I don't know if I'm hearing you correctly, but
go
the,
back to your photo, your text file.
okay, I'm back at my text file.
Line 16, this is like the number 4,
Uh-huh.
minus 1.
Oh, you can't put -1 in there because minus is not legal as a Python naming character. So Python's naming, Python's identifier syntax is different from XML identifier syntax. In XL, you can have hyphens as parts of identifier names. And a hyphen cannot be part of identifier name. So it's saying plus underscore -1 is interpreted as a variable name plus underscore, not defined.
Well,
No.
For the definition of the plus, and in terms of the int, you can put in other than a number, or you can put words like this.
Let's try it. Watch this. Let me go to my original definition. Plus, let's see, concat, let's see, 10. Plus n, my prefix. Because plus loaded, plus for strings is different than plus for numbers. Plus for strings is concat.
Never up.
Pardon?
We're up.
No, this point. You're not off tangent. It's a terrific observation, and that's the point of this sort of a course. You are things that you ask questions about them and push the envelope and try things. It's a terrific question. Oh, okay. So I equals 4, J equals 5. Stir again, we're not yet in the object-oriented part of the class, and I've just mentioned her in Repr and passing. The Repr are two classic Python built-ins for expressing the value of an object in a way that people can use. The stir built-in is supposed to give you a human-readable representation of a particular object, something self-documented. I just happen to know that stir for numbers gives you back the ASCII encoding of a particular number. Rep is a little bit more precise than stir. Repr is meant to give you a representation of the object in string form. And I showed you this before, and it might be worth repeating. I think that this particular point is worth repeating because I use it in debugging, and it's a really cool feature. I can say something like Repr of, if Repr is working, if you have Repr working the way that I like to see it working, if the Repr of an object and you evaluate, you get back an equivalent of the original object. The reason that I find this useful is that a common problem that I run into when defining debugging complex logic is what the internal state look like at a particular point in the programming process. And Python, what I do is I will use Repr to take a snapshot of my object. If my object is defined correctly, that stringifies the object. I can look at a string, pick around with the string, I can evaluate the string to get back what I had at that particular point in the computation. So, again, questions, but useful. Right now, I'm working on a project. I'm working on a project for Ronnie and Bobby. I'm working on a project plan. And one of the elements of my project plan is in every object in the system and developing a serializer and bulk loader, that class of objects. Serializer is a dumper, is Python, the phrase is pickler. Different languages have different definitions. A serializer is something that takes the state of the object and pulls it out in a way that you can bring the state back. And that strategy for system design adds overhead up front. I think about is whenever I think about new systems, I think about the Fram oil filter commercial. And I don't know if I've shared the Fram oil filter commercial with this particular. I don't know if anybody remembers it at all. Okay, a classic commercial. You see the commercials from the viewpoint of a customer. You don't see the customer, you just see the mechanic. The mechanic is standing there over the car and said, "Bad news for you, Mr. Jones. The engine's going to need a total rebuild. Unfortunately, it's going to cost you some money." But then, again, I think this was probably going to happen when you were in the shop last time, and you said, "Give me cheap oil, the cheap air filter, into the good air filter." As I said, Mr. Johnson, you can pay now or pay me later. With occasion, of course, the payment later is more expensive than payment sooner. One of my cherished philosophies of systems development is to pay up front. And one of the costs that you pay up front is to develop these inspector and reloader methods. You factor that into the initial cost of development. And when you have those, what's the single hardest thing about building a system, right? Debugging the tools. If you can debugging tools, in place before you're ready to debug, then you have done yourself a favor over the long term. Oh, so let's go on to yes.
So I thought for, an overload, just put a certain number in
Mm-hmm.
the, another one,
Okay,
there's no overload.
Dave, so John, I should be repeating comments, so I'm sorry, I'll start doing that. What he's saying is that he was trying to force +4 to overflow. And you can't do that in Python with straight integers. That goes back to one of the first sessions where I showed you that Python has big numbers. If you remember that one example where I had you raise 2 to the 1024th power and Python sat and ground a little bit and then produced this string. Now, no, what happened is memory will crash. Now with Python, let's see. What Python does have is a max size built in. I did with my Python class in fall 2012 is have them first couple classes write a loop that shows powers of 2 to the first, to the second, to the third, and then have them get sys max size. And what sys max size was doing relative to the powers of 2. And if I heard of the class could not figure out that this was 2 to the 63rd power minus 1. Even after I had them write the loop to print out the powers of 2. Okay, it's 2 to the 63rd minus 1 in each one. This yeah, it's the largest positive number that will fit in 2's complement arithmetic if you have 4-bit value. So size is telling the Python implementation is that if you're representing integers that go larger than this number, you have to use multi-word representations, meaning into string arithmetic. The reason that Python will deal with larger and larger numbers, what will happen is the process will slow down because Python at some point shifts over to machine size, doing everything in one word, to doing things with strings of numbers. And whenever you're doing math on strings of numbers, for example, multiplication and then squared, and you want to know why multiplication and then squared, think about the old exercises where you wrote down a four-digit number times a 4-digit number, and you had to multiply every pair of numbers and add the column. So the string arithmetic slows down because if you have multi-byte numbers, you eventually, for multiplication division, have to match every number against every other number to get the result. Python will keep going, but it will get slower as your integers get bigger. Now, however, Python will overflow floating point. Okay. So hearing that, I was wondering, can I do this? And it blew my mind a little bit, but I figured out how to do it. Try line 1698 through 1704.
It's a counter.
Yes, exactly, Dave. get that to work properly.
You should live in there, think about for a while.
Does the example make sense to you? Right example makes sense to you?
Yeah.
John, example makes sense to you? Okay, yeah, and Patty, does the example make sense to you? Let me expose it. My system, half, we're divided here. Half the people understand what's going on, and half don't. So a paste would defer that. They get F initially, right? Now what is when I call it F? Or F? These things is not like the quota bit of our time. What changed between the first and the second row? The XN. In that change. No, that doesn't account for the box. Yes. Okay. C equals is what's referred to as an if expression. If coded C, it's like the question mark colon operator in C. So what do we? It doesn't have an X. If F doesn't have X yet, 0. Otherwise, take the value, step it by 1. Like our objects. Objects are containers. That have a bunch of attributes. As there I have a particular attribute. So the statement says that X, the function, if the object F does not have an attribute X yet, so it is 0, otherwise implement it and return the value. Are you said with that, John? Patty. Okay. Okay. Yes. The functions, I read a fiction story once that talks about getting people's brains to become plastic. What's going on if you've only lived with how languages is getting used to the idea that everything in interpreted language is potentially plastic. Unlike in a compiler where you compile a function F and F has set variables and you have nothing else to work with. But objects can add attributes, they can lose attributes over the course of the computation. The explanation makes sense. Not really. Is there a distinction between a function and a class? Yes. The distinction between a function and a class that classes inherit and functions don't. technically, there is no distinction between functions and classes. Both are just widgets that have a bunch of slots. The difference is that classes, one slot is occupied by a construct that says that the class is inherited. Stuff from another class, from a superclass. Okay, so move right along. I closed with last time in a different form. Try line 1709 through 1715. Does anyone recognize the quote? You remember? The doors. Too cheery for the doors. Hey, if you recognize the artist.
You hear me?
No. Still old. People probably heard this. I'll skip to the chorus. Okay, so if the function do what it purported to do. Mission impossible that they've terminated at. Okay. Again, the point is not to go down memory lane, although we've done that, or to do stuff that you shouldn't code with. But the point of these examples is to try to impress upon people that you're playing with a whole lot more flexibility. Which is another prophet of our time, Stanley, who once said, with power comes great responsibility. Okay, that's the end of the function examples. Does anybody have any questions before I go on to discuss scoping in Python? So, in compiled programming languages, is fairly straightforward, mainly because you have to declare variables before you use them. Every variable has to be declared. Languages require that because the declarations are needed for checking. In Python, as you've seen, to create a variable, you can bring a variable into being without declaring its type. I equals 3 or I equals 4. And that creates potential issues because in addition to creating variables, you can also nest things. functions within functions. You can also put functions within functions within functions within functions, and so forth on down. And it is right functions that are deep in an environment where you have variables declared above within other functions and variables declared all the way out at the top scope. Then there needs to be some way in the language of disambiguating which n might be referring to. You have an n that's two functions above you, and if you have an n that's all the way out at the top. Solved your problem by saying all variables are global, which surest ways of shooting yourself in the foot in programming language that I know of. It takes a different approach to scoping. I default effectively all creations, all create operations are local. If you go create a variable and other stuff isn't in play, the variable created it at your local scope. All read operations by default are local or global. Default, if you were trying to read access a variable n at a deep scope, then the interpreter works its way out through the nested scope. Every new function opens up a new scope, and you get the innermost definition of n as you go up through the scopes. So if you have a F inside of F3, inside of F2, inside of F1, and all things being equal, you say n equals 3 in F1, and you have n sitting out here. Treat this n as local to the scope of F1, which is what you want, because writes are potentially destructive to reading about a program's behavior. Reads are actually cost-free. It's the writes that cause the problem. On the other hand, you say print n, and n is assumed to be n that's innermost. Here would be n defined in scope F3. Here it would be the n defined in global scope. Ways of overriding these default assumptions, I'm going to put you through a series of exercises that show the scoping rules. There are, in Python, 3 scopes. There's local scope, there's null scope, and global scope. I want to keep in mind for this particular set of exercises. Before too much into them, the language professor who said about a programming language, of course, it said visual concepts in isolation are typically simple. It's the interaction of concepts creates conceptual difficulties whenever you're working with programming languages. And it's the interactions that are really hard for the language designers in some cases to come to grips with. Now, you may never, when you Python, end up doing the sort of examples that I'm showing here. thought it important to cover scoping before I went on to some of the more common used aspects of the language, in part because if you ever need the rules, I have them in my notes, and in part because references I've seen don't cover this stuff. In order to figure out what's going on, I had to go in and construct these examples. I have seen these examples anywhere in Play and any other references. And one of the reasons for bringing this point out is, once again, this issue of when I use a language, I don't like to be surprised. I like to know what's going on in the language and by doing simple examples. Three, it's the classes, which we haven't seen yet, and opening functions creates new scopes. Functions, nesting classes, you can nest classes in Python. I'll show you an example of a nested class. It's out that nested classes are nice for the same reason that nested functions can be. So, Python has no local declaration. You get around Python's built-in rules by saying an identifier is global or by saying an identifier is non-local. And that's all you have. If you have a stack of functions and you have an n here and an n here, there's no way that you can get at the NF4 because n and F3 will shadow it. The idea of variable shadowing is classic. It's the sort of rules that I used to see in languages called ALGOL. I think that some other languages allow you to say specifically F4.n. Python doesn't allow you to do that. Okay, so here are the rules. And we'll show some exercises. All fires in Python's outer scope are global. If the variable is global with the global scope, that's perfectless. If you say variable is an identifier, not variable, identifier. An identifier is non-local with the global scope, Python gets sick. Who cares? Okay. That makes sense, because you're not in an inferior scope. The identifier entered once as a global, as a non-local, or as a formal parameter. Something like this. This no can do. Okay. There's rules that I think I believe that Python uses to distinguish. If its name is a global, then it's global. If its name is non-local, then it's non-local. Is as a formal? Yes, it's a local. Is X read before being updated? Yes, X is read from the closest and closing scope. Otherwise, X is reusable. Here are some examples. Let me have you run the code lines 1835 to 1844. modern comments are out of date. Actually use numbers and then decide to use strings for clarity. Yeah. I'll update my comments. Sorry. Okay. Well, we are where we use this mention here. Okay. Okay. Yeah. Oh. I'll just, that's wording, just leave it at that. So this first example is printing global rather than the non-global. Let's just declare it as global. Any questions about the first example? Any questions about the first example? Patty? Bobby? Okay. Second example. Try that. Second example is interesting. It's really important that I didn't intend for it to be, but it's really important. Understand what's going on, and then this on line 1856. Focus carefully on line 1856. Okay. First of all, do you understand why this is blowing up? You understand why the definition is blowing up?
No.
Do you understand why the definition is blowing up? Do you understand why the definition is blowing up? I'll explain the group in a minute. If that's okay. And do you understand why the definition is blowing up? So, Bob and I are the only people in the room who understand why the definition is blowing up.
So the reason for that is that, well,
1851, 1851. We write the other way around that. 1850 is executed before line 1851. Once 1850 executes, X is determined to be a parameter. You can't then re-scope it. Now, the reason that line 1856 is really important, and I've shot myself in the foot so many times in Python, having happened to me is that since the definition at line 1848 did not take, the definition that at line 1837, the first definition you put down is still active. What's happened to me in this language is it loaded up a bunch of definitions. I've done some work. I've loaded up a second set of definitions. I knew that one of my definitions in the second load doesn't take. The program still runs. But off the old definition, and there's not changing. And by the turbo, I'm saying, what's quite wrong? I changed code. Well, I changed it, but the definition did not take. And talking with you, they the best practice in this language, putting modules, and this is a concern that just hit me right now, to make a point of undefining everything. Reload. So let's go on to the third example. Third example is just showing that the global doesn't affect find the return of the X in 1864 to the outer scope value rather than to the X at line 1860. Brian, are you satisfied with that? Are you satisfied with that? I'm satisfied with what I'm saying. One of the examples, line 1864 and 1860. Line 1860, 63, and 64 are the key lines of this example. 863 is binding to the value way back once upon. Happening is that the X non-local is being bypassed. Non-local of X is being bypassed. That a parameter is a non-local in integers. Okay. Bobby, are you okay with this? So let's go into one more. And this shows how it makes a point about if you have an X and it's not defined anywhere in the inner scope, it does go all the way up to the global scope. So this is the simplest of these examples. Four that show non-locals, how to get non-locals, and three that show locals. Let me lead it up to the crew. There is one example that I'd like to show. Do you wish to run through all 7 examples here? if you all say some examples, let's do it. I think one of the most important example for the non-locals is the third one. So we'll go through one. The first, 1987, see if people understand it. 1999, see if people understand it. I hope be reasonably self-explanatory. What's happening in this first example, 81 reset value at 1888, and now she is printing. Okay, go on to 1899. Straightforward. Now that I'm looking at this, I could easily have made this example the first in the series. It should have been the first. It could have been the first in the series. The whole is the reads go up the chain. Okay, third one, in 1909 is the interesting one. Now, us for a minute after this. Book syntax here. Yeah, piece of syntax there. Do you see Brian? John, do you see the syntax here? Message. Do you see the message, Patty? See the message. Okay, what's going on here? Python's attempt to deal with an ambiguity. You have F4, F3 including F2 enclosing X1, F1, and you say no local. Now, only had F4 inside F3. There's a scope that the non-local could be part of, right? In the scope, it's non-local to F3, and that's F4. Python, in theory, ought to be able to handle that case. Python is not. Python, the parser is, I think, geared towards this case. You solve it with, say, non-local in this particular example. That example is just saying X is somewhere outside of me. It does whether X is an F2, whether X is an F3, or whether X is an F4. Declaration is ambiguous. Python requires if you are declaring a non-local, you'll have the local active by the time you hit the declaration, either as an assignment or as a parameter. Complains that they're finding for non-local X because Python is saying, I don't know where X is going to be home. Again, there's this trap. You see, he just missed the syntax error message. If you don't see that syntax error message, then what you get is the value of F that was defined one before. So now that I'm teaching this material, I'm remembering some of the problems I've had defining with the language. It seems like it would be a best practice if you define an F to put, before you define an F, something like this. You've seen this before, right? And under what? And that's the problem of getting a stale definition after you had a failed definition goes out. Okay, so let's last one. Are you comfortable with this last one? Okay, fair enough. Patty, does that make sense? Again, the point is with the non-local, to work with the non-local, you have to home the non-local somehow before you declare it. You have to statically home it, so Python knows where to home it. Bobby, are you good with that? Ryan, you good with that? Okay, and let's go on to the last set of examples, which are the local, and there are only 3 of these. 2, they're valid.
Wow. Try to make it.
Actually, there is one interesting. There is one interesting example that breaks. But I don't have it here. I wonder if that's one that, if I commented that incorrectly. Let's try it. No, there's an error in the comment on the second one. I will get updated out the next time around. It should say no. Let's see. Yes, that's wrong. The second one is not valid. That's why. That's the interesting one. first example should be straightforward. Let me ask about the second example. Do people see what's going on with the second example? And do you see what's going on with the second example? John, see what's going on with the second example?
We put that on
Yes.
it.
I'm sorry. The first example I said should be straightforward. We'll bypass it in the interest of time. Let's go straight to the second. I will run it. Yeah. And the rule for saying variables that have not been explicitly scoped happens if you have a right of the variable. What's the right of the variable that has not been scoped? What scope is it going? Global, non-local, or local? Local. Right? The safe thing to do, going back to this basic principle, is whenever you read, feel free to read from anywhere. Whenever you write, try to localize rights, because if rights become non-local, they have side effects from other logic. So the X assigned means that X is being put in the local scope, whether there's an X at global level. What does the sign do? Assignment, right? X equals 3, X plus 7, X. Class the operator, incremental, take the value and update it based on its current value. X equals some string, X equals with X. Okay? So the difficulty with this example, and I actually blew up a program before I figured it out, is that the X is being assigned to local scope, but though you have a value of X in the local scope, X is undefined. And if you get the error messages, that's what the error message is telling you, a local variable X reference before assignment. So the way to fix that is with example 3. Prime the value with a strict assignment rather than incremental assignment. And then at that point it becomes safe to do incremental assignments, incremental changes. I will start a little bit of the yard stuff before we close out. Before I do, send one quick pass through Patty. Is about the scoping rules make sense? Mm-hmm. John, right? Do the coverage of the scoping rules make sense? Bob, scoping rules make sense. Okay, so this will work next week. Varargs and keyword arguments, and before we get out of functions, varargs and keyword arguments and lambdas, and then we'll be finally out of the material on functions. Have you seen varargs and seen varargs before in the context of C? dual. Bobby, you've seen the Varg stuff. Ryan, seen the Varg stuff? John, seen the Varg stuff? Patty, have you seen Vargs? No. Exactly. Okay, so this is a little different. This is more of what you can do in Python. Python does not support overloading. Var and keyword arguments are important in Python because Python does not support overloading in the object-oriented sense. Have a definition of FAB, and then to define FABC. Who's FAB? It's gone. Okay. So what you can do in Python is define something more general, F of arglist, and vary the behavior of F based on how many items you have in the arglist and what types you have. Very much classic C. What I want you to do is to run the example from lines 1984 to line 1988. So you've seen Varg, you should be satisfied with this. Everybody's seen Varg, so this should be fairly the old stuff to you, right? John? Patty? Simple enough?
Yeah.
Run a couple more examples. If you do an argument list, the main difference, look at the difference between line 1988 and line 1991. That's the point of the second example. It was the same thing, but by 1988, on the entire list. In line 1991, creating a list ahead of time, and I'm passing with a star in front of the list to indicate that I want the list into different values as part of the passing. Show what I'm saying. Notice the difference between these two calls. I should add my example. Notice when I call a star arc list, when I call a plain arc list. Oh, good. Okay. Ryan. Are you good? And my master notes, I need to show both of these. Notice what happens when you leave the star off. So star is doing this, it's flagging what's on and saying, yes. What if we do the last, I think there's time to do apples left in the star stuff, 1994. If we example line 1994, then I can remember 2000 is a good round number to be bought at. And I'm not going much further because I've thrown a lot of subtlety at people today. And point heads explode. The difference between this example and the last example is I'm using enumerate to make it a little bit cleaner. Or to say, and that shows the difference between the use of what you can see between using star with the list, listing your stuff out, and with some passing the list. Are there any questions about what I've gone through today? I'm going to add to my notes, and I'll circulate updated notes next week. Start right around 2000. Dave, are you good? Dave is good. The rest of the world is good. Except for Iran and North Korea. I got down for another week. Does that make sense? Bob, are you good with that? Okay. Dave is signaling okay. I'm going to leave the meeting, which basically